Okay, so hello and welcome back to another roguelike tutorial. In this one, we're going to be taking off from last time where I had simple player movement and I could shoot and these things can die. These are like the training dummy kind of things. Obviously everything's still in an early stage so far, but we're just implementing the mechanics. In this video, we're going to add smooth camera movement, so when the player moves, yeah, the camera follows rather than just running off the screen. And I'll also add enemies shooting back. Yeah, I'll do that, that's a good idea. So, first of all, we'll do the camera script. So as you guessed, the script will be going on the camera. We will add, I've already messed around, so we'll call it camera follow script, well, camera follow player, whatever you want. And let's go put that in the right folder. I already have Visual Studio open ready. Let's put that in the script. So this is basically, well, I'll show you the reason why we use this. Obviously you need some scripts in the first place to actually have it follow the player, so we'll set that up quickly. So we need a public transform player. Now, oops, I'll just type out. Okay, public transform player. So transform it is the component on something here, this. So basically, yeah, doing this means we can get its position, rotation, scale, all that lot. And what we want to do is we want to make the camera move to the player's transform. So that's why we're getting a transform, not a game object. You could get the game object, then get the transform of that game object, but it's just no point. So get the transform of the player, and we also want to take in a float for the amount of smoothing, but I'll leave that out for now. I'll just put float smoothing. We'll just not use it for now. So let's say void update. Obviously, I will be showing you how to improve the script. So void update. What do we want to do every frame? We want to say transform.position, which refers to the camera's position. We're going to set it equal to the player's position. Now this is not what we actually want. This is just showing you this is where you might start when you're just messing around. We're going to get an error first, which if you haven't guessed already, it's because we're trying to set it equal to the player, but we don't know what the player is. So if you look down here on the camera's code, it says we need a transform. So if you just take your player and drag it in, there we go. So just give that a second, and now we are following the player. But the problem is, since the camera needs to have, it needs to be further away from the sprite, so it's actually looking at it for it to work. So its render Z depth needs to be so that we can see the player. Currently, yes, everything still exists, but we can't see it because we've set the transform of the camera directly to where the so if I move this position now, you might well see it for a second. Now you literally can't see it because every frame it's saying it. So the way we can get around this is we can add an offset. So if we take also a public vector free offset, so public vector free x, y, z. If we take in an offset and then we say transform position equals place position plus offset. Doop-a-doo. Okay, so now we can set the offset. So if I put -1, there we go. So now we're actually away from the player, and as you see, the camera is set to the position of the player, which you might want for your game. You might want your camera to be fixed to the player, but that's not great. Now one thing is, update is depending on frame rate. Like if we have a faster frame rate, it's going to look smoother than if we have a lower one. We want it to be fixed to 60, so we'll say fixed update. It's the same as using time.delta time on a line, but this happens for everything in here. We want everything to be done the same way. One sec. So now what we want to do is we want to make it so that first we'll do a check, because what if the player dies? This code's still going to get run on the camera for following the player. So we'll say we'll make sure every frame before we actually do it, say if player does not equal null. So we'll make sure the player exists before we run any of this. Obviously, yes, it's an extra check every frame, but it's definitely worth it because it stops crashes basically. You could also have it so I guess if the player dies and disable the script, that's just a weird way of doing it. This is fine. It's not going to cost you anything really. So we're saying, yep, the transform is the same plus the offset. Now because I changed the offset in play time in the editor thing, we need to actually set it outside of the editor for it to save. So just put that to -1. Now the smoothing variable. Basically what it's doing now is every frame it's setting this, but we want to actually use a Lerp function, and Lerp is basically, it takes in two values, an A and a B, and it goes from A to B, but instead of just going instantly to A to B, from A to B, it does it like as a percentage. You put in, it takes in 3 parameters, and the third one is basically how fast you want it to get there. So I'll show you this in action and explain it a bit more. So currently, we're just setting the position, but first of all, we want to work out a vector free. We want to know where we're going. So I want to say vector free like new position. Whoops, position equals. Then we'll say vector free dot lerp. Now if you see it says lerp linearly interpolates between 2 vectors, a, b, and t being time. So let's put in our 3 variables. So the first variable, we're moving from one to the other. So obviously, as I said, we're moving from our position, so transform dot position. We're moving from that to the player's transform dot position plus the offset. I'm gonna get rid of this basically. And then the last parameter is how fast. Now this is going to be the this is going to be the smoothing variable, which will change outside of the script. And then once we've calculated this is then when we set it equal to the new position. So we're actually working out where we want to go rather than just saying, we'll just go to where the player is. So let's go and test that now. We'll give smoothing a value. I'll do it in runtime so we can, tweak values to see what we want. But you want a very small value for this, otherwise it won't be noticeable. But you don't want it to be so small that it doesn't really stick to your character. So if we look now, it's just not moving at all because the smoothing is 0. If you put it to 1, it's basically fixed, to be honest. It moves very fast. Well, the 1 is fixed actually because it's does it instantly. Put 0.5, as you see now, it's like as I finish moving, there's a slight, very, very slight kind of lag behind. If we put it something like 0.2, you'll start to notice it more. But obviously you want to go down into like the 0.1s maybe. So as I move now, my character moves a bit off to the left of the screen as I'm moving left. And when I let go, it kind of like goes back to the character. Now this, you want to tweak this value to what feels right for you. I actually, when I was testing earlier, I found 0.05 was quite a nice value. So you're running around doing your stuff, and then it kind of like smoothly locks to you. It's smoothly following you the whole time, and you're always going to be in the center of the screen. There's always like this kind of area here where you're going to be regardless of like what's going on. I really like this effect, and obviously this is all optional, but I feel like it's a good addition to the game. Obviously, you can still play while, going around doing all this stuff. It's all nice. So that's one function, one thing we need, obviously the camera following the player around the dungeon, otherwise it would kind of ruin it. Obviously remember to save your project every so often. And then the last thing I want to do is, on the enemies, we'll just make a simple thing for them shooting the player. I thought that'd be a nice thing to this video. So what we'll do is we will make a script on the enemy called test enemy shooting. The reason I'm calling stuff test is because eventually we'll be creating specific enemies that have specific abilities and movements and behaviors. So for now, we're just setting up a test thing for like all the systems, and then we can expand upon them one at a time. We want it all there so that we have like a kind of, think of it as we have a prototype game first before we actually start making everything properly. Everything so far is going well, so it's all good. And quite a few people are wanting this tutorial, so I thought I'd keep going with it. And I shall anyway. So this is on all the enemies now. Well, if I press apply to the prefab, it will be. So you see, these all have it now. We want to take, let's see what, it's going to shoot just like the player. So it's going to take in a public game object projectile. There's a dog out in the street, sorry about that. If the barking's getting on your nerves. So we have a projectile. Now, to be honest, what we'll do is we'll just open up the player script here. Sorry, my throat is dry. I need a drink after this. So yeah, min damage, max damage, projectile force. To be honest, we can just take these same parameters. We're going to be using them for this. The only difference is here we take in the mouse button click to shoot, and then we run this code. We're going to be using something called a coroutine, which is a good way of doing cooldowns and stuff. So instead of like using time.delta time, which is still a viable thing to do, you want to use coroutines because it's just so much easier, and it's very good for ability systems in games and having bits that wait time. You'll see why in a second. I've covered coroutines in other Unity videos, so assuming that you've not come straight to the series, if you have, I recommend watching the other videos first, probably, because they're quite relevant to any game. If I remember correctly what videos I've made in Unity. But anyway, we're going to use well, in the start, we're going to call a coroutine. Now, to call a coroutine, you have to actually type start coroutine, you can't just put the name like you would normally run a function. And we'll call it, you know, shoot player. So that's the thing. Now it's going red because we haven't created it yet. So to create a coroutine, you make an I enumerator. That's just, instead of putting like void start, void this, update, function name, you put I enumerator, then the function name. So shoot player. And this was going to stay red until we return something. So just bear with me for that. So currently when we start, we're doing this. Now what's it going to do? We'll say yield return new wait for seconds, and we'll put a cooldown. So let's just put a public float cooldown. Okay, this line, I could actually make a separate video on enumerators, as in coroutines, if you want. Think of it as if you've ever coded in a normal scripting language, like if you've ever coded in Python or something. Code is run like in order until it comes to a stop, and then it does the code or waits for it, like waits for an input, and then it continues going. Whereas in Unity, code normally is run every frame regardless. It just keeps going and going and going. Enumerators are basically just like Python in that sense. Not obviously, Python is just an example. It's where like we'll run the code, but it can stop and wait. This isn't frame dependent. This is just dependent on, you know, what's going on inside of it. So this is literally going to pause the running of the code in here for this many seconds, the cooldown, and then it's going to run it. So if we now make like you know, like we'll call it, we'll do what I did in the other one, like game object spell equals equals instantiate projectile, and we want to spawn it at my position with, well, the rotation doesn't really matter. So we've got ourselves a projectile at the player now, at the enemy, and then we will, in this one, you see we take the mouse position, spawn it, well, move it there, blah de blah, fire it in a direction. We literally just want to fire it in the player's direction as soon as it spawns. So what we can do is we can say vector2 direction equals, now in here we get the mouse position to my position. So what we're going to do in this case is we're just going to get the enemy's position to my position. So if you remember correctly, because we're using 2D space and vector 2s, we're going to say vector2 my position is transform.position. So it basically removes the z. It just gets the x and y. It doesn't ignore the z depth. Now the vector2 direction, we are going to take the player's position. So I need to have access to the player here. So public game object, well, public transform player, and then we'll say like every time we run it, we'll say like we'll just make sure if the player does not equal null. Oh, oops, why have I put that there? So if the player doesn't equal null, we'll then do all this. So basically, if the player's still alive, we'll keep shooting him, is what it means. I mean, actually, in reality, in reality, no. The problem with this, okay, is we start the cooldown if we've made sure the player's alive. But what if the player dies while it's on cooldown? It's going to cause a problem. So, sorry about this. We're going to remove this, actually. We're actually going to go and put the loop after the wait. If player does not equal null. There we go. Alright. So now we've got that. Player dot position minus my position dot normalized. Oh, what's it doing now? Player dot okay. We also need a vector2 target position equals player dot position, because we need to take the player's position into a vector2. So target position dot normalized. There we go. And then now we can just fire it in that direction. So we can just say spell dot get component rigid body 2D dot velocity. Oops, brackets. Dot velocity equals direction times by projectile force. and on here it sets the damage, so we can say, you know, spell dot get component test. See, this is called test projectile. I'll call this new script. We're going to make like test enemy projectile dot damage equals random dot range min damage comma max damage. Okay, this is all done now. It's going to throw this error here until I actually also at the end of this coroutine we will then run it again. So we'll say start coroutine shoot player. There you go. So it's going to basically do this, cool down, do this, cool down. Now what we need to do some tweaking first. We need to create one more script and then we'll be done basically. So if I wait for it to compile and go to an enemy, it's not gonna actually do it yet until we make the other script. So let's make it now. Create a new C# script. We called it test enemy projectile. I did spell that right and do it all right. Yep. Let's move these into the scripts folder. Let's also like save this. Oops. Scripts. There we go. So it's gonna need a damage variable. So, you know, public float damage. Have I got a projectile? Yeah. So in reality, it's just going to be the exact same as this with like one line changed, which is just going to be making sure that instead of it not equaling player, we're going to make it not equal test enemy. Well, actually, we'll say collision.layer dot tag. Yeah, collision. If collision.tag does not equal enemy, because we don't want enemies to be able to hit each other, then get the component like player. What do I call the player stats? Have I not made the player stats? I don't think I've done that yet, actually. No, I haven't. Okay, actually, I'm going to save this for the next video. So what I'll do is actually, I'm just going to comment out. I'm just going to get rid of this. And just say, if it hits the player, then destroy it. I'll do that next video. This video is getting on quite a bit. You can probably figure that out yourself anyway. I just don't want this video to drag on too long. So yeah, it's going to just destroy itself when it hits them. So we just need to put a script on it. So we'll go to where the projectile is in prefabs. We're going to duplicate it and call it like test enemy spell. And then we'll just say like, we'll give it a red. Is it not wanting to go red? Oh well. Oh, it is going red, okay. We've got a circle collider. It's basically just the exact same thing. So let's have a test to see if this works. After we've given the enemy a test enemy spell. Because if we give them the player spell, then it's going to destroy them themselves. So projectile, and then the player, apply. And we just need to make sure the enemies are also on, they're also tagged with a new tag called enemy. So if I go to the like an enemy, give them the tag enemy, and then just apply the prefab, then they're all tagged enemy. Let's have a look. I've done a lot without testing, so we need to make sure this is oopsie daisy. Alright, what's the problem here? The test enemy projectile damage. Spell dot get component test enemy shooting. Because for some reason it's not applied that. Is the player prefab not saved? Okay, they all have the transform now. I swear I pressed apply earlier, but clearly I didn't or something. Oh no. Now, they're all spawning, but they're all missing... Ah, that's me being an idiot. I didn't actually put the script that I wrote onto the object. That's silly. Test projectile, remove. Test enemy projectile damage. The damage doesn't matter at the moment because I haven't actually made the player health. I'll be next video, I guess. That's a good thing. Alright, so... The only problem I'm getting now is that they're not moving in the direction of the player. Reason for this being... Well, let me think. Well, they're stopping on the enemy. Well, actually, no, they're spawning on themselves and then disappearing instantly, meaning that if the collision.tag does not equal enemy, let's print collision.tag. Sorry if this video is dragging on. Did the tags not save on the enemy? So, okay, I get it. So what's happening is it spawns some, but then before they get to travel to the enemy, or to me, the next ones are spawning, and they're colliding with each other, and the projectiles are colliding with the projectiles, and it's all going wrong. So, the only problem is, for some reason, this coroutine, it's because I didn't give them a cooldown. Silly me. Silly me. Cooldown should be like 4 seconds, and the 4 should be like, what force I give the players? 2. So 2 as well. This is going to be a bit hectic now. It's going to be like a bullet hell. Well, okay, it's not going to be that bad because I've given them a cooldown of 4, but now they aren't. Oh no, they are shooting. Damn. They're just all synced up shooting. I should pick like either a randomized cooldown or make them all spawn shoot a bit differently, but hey, it works. It gets the player's position and shoots. Yeah. Okay, so that's finished the video now. I'll just have a quick show you the code. You should be able to go back and see if you need to. So here we go. That's the shooting. Here's the actual projectile code. I'll expand on that one. We've got the actual player health and stats. And then here we've got the old projectile for the player to shoot. But hey, so now we can kill enemies. They can shoot us. They will be able to kill us next episode. And we've got smooth camera movement. So I hope I've covered enough. This is a 22-minute video. It's getting on a bit. I've still got plenty to cover in this series, so I'm going to keep making videos every 3 days or so in this series. So yeah, thanks for watching. Obviously, if you haven't subscribed already, then that would mean a lot to me. And obviously, comment what you want to see more of, what mechanics you want me to cover or think I should cover, so on. Same with all the other videos. Show your support. I respond to practically every comment, so if you want to ask a question, then feel free. Also, if you haven't, join our Discord in the channel description, where we have discussions and you can ask for help and this, that, and the other. But yeah, so thanks for watching and goodbye.